If you would like to put your hands together, we can introduce Dave Schwartzberg, and he's going to make us a lot smarter about Meshtastic.
No, my name is Heel.
Heel, sorry. Heel.
Now I can't see. Thanks, guys. Thank you. Yeah, I go by Heel. That's in the slide. But, hey, sciatic nerd. So I got to tell you, I am super thrilled to be here as the final Belay It presenter for 20 minutes at ShmooCon. This is my first ShmooCon and my last, but I'm just thrilled to talk about this subject. I hope you are excited as well, and I hope you enjoy it. And I hope you don't have any expectations I can't live up to, but you know what? Too fucking bad. So we're going to talk about Meshtastic, Attacktastic, because it was a cute name to start with. A little bit about me, real brief. I go by Heel, it's my name. I've been in the industry for over 29 years. I work at Cisco. Next month will be my 7th anniversary. I'm one of the co-founders and creators of Hack for Kids in 2014. Thank you. It's a board member. It's a little setup. B-Sides 312 in 2023. Yeah, again, board member. Day after ThoughtCon, so if you're going to go to Chicago for ThoughtCon, stay an extra day, have some fun, hang out with us at B-Sides 312. So in my career, I started as a land administrator, and then after about 5 years, I kind of switched over into the vendor and manufacturing world of things. So I thought it'd be pretty cool to work for Novell and know how those network things operate like at the low level. And I've been doing that really kind of ever since like 2000. My background kind of spans things like email hygiene, encryption, endpoint protection, edge protection, threat hunting, malware research, and building custom electronics for, we're a Badge Life member at Hack for Kids. So I've done a bunch of things. I've been around for a while. And so kind of also outside of tech, I'm really passionate about things like making barbecue, as you can see in the picture, curing things like bacon and fish, but not smoking them at the same time. I don't think that's kosher, which is fine. Making corned beef from scratch, I just did that a couple weeks ago. Crafting my own ketchup. Last weekend I made Chipotle ketchup, phenomenal. Get rid of the high fructose corn syrup and all the other preservatives. Do it yourself, it's super simple and easy. And if you want, we could talk about that. And I also do a lot of volunteering aside from Hack for Kids and in the security community, also in scouting. If you're familiar with anyone here active in scouting? Scouter? Yeah, Silver Beaver recipient. I've done a whole bunch of things. I've never been to Philmont. I've done Wood Badge, been staff on Wood Badge, and I'm going to be going back to National Jamboree in 2026 as the Scoutmaster for my council. For those of you who do not know what I said, don't worry about it. I do a lot of stuff with kids. Moving on. Let's see. Of course, the talk is reminding me that I have a talk. All right, there we go. So quick look at the agenda. Just going to talk about Meshtastic, going to talk about LoRa, going to talk about some of the security concerns. And if you've been practicing security as long as I have, you're going to look at this and go, yeah, we know, I get it. But there's a really cool POC coming after that. And then just cover some best practices, especially for somebody who's not familiar with anything like radio frequency or any of those kinds of transmissions. I also forgot to mention I'm a ham. Tech license, KD9HCA, CQ. So these are what some of the devices look like. So Meshtastic, at its kind of core, it's just open source, decentralized communications. It's a platform that's going to allow users to create these off-grid, long-range mesh networks. And if you've been on the network, you kind of see here it's been pretty busy, which is actually really, really, really cool. So primary use is related to things that are low power. So you can have a battery that's 1,200 milliamps all the way to whatever you want to carry around with you, but it generally operates somewhere around like the 3.3 or 5 volt range. And also these LoRa devices, which we now know is long range, thank you sir, good job, is also something that's not only enabling these messages, but also GPS. So if your device has GPS, you could then beacon where your position is. Great for anything that, again, is off the main grid or where there's no internet. And these are just some examples of things. So you see a picture in the Chicago area. It's pretty active. There's some stations there, as well as some users. You saw the video of the little T-Deck, which is kind of fun. 3D printed the case, and then some other devices like the G2s here. So this is a Nano. You could also get a station, which is what I have at home running. And then the little guy with the antenna is, or the white one is a T-Echo. It's a LilyGo. So the architecture, fairly simple and straightforward. You have an app, Android, Apple OS, iOS, doesn't matter. So you put the Meshtastic app on there, and you could use Bluetooth to talk to your node. Your node is going to want to talk to other nodes using that LoRa radio signal. Now, you could also use a browser. So you can use Serial to flash your node, which those new nodes that you have, they're probably going to do that. And then after that, you could also use Wi-Fi as a way to manage it, or Bluetooth, again, from a PC or laptop. And then the other devices downstream in the node would then forward any kind of messages. Simple, right? Just no internet, that's the point. So some other key features. The primary feature is the mesh networking, but it's also going to want to do other kind of relaying to the other nodes, like I mentioned. You're going to want to use a hop count. The default is 3 hops, but you can configure up to 7. So the hops is just to make sure those messages don't kind of perpetuate. You know, it's like a TTL, like on a ping. The off-grid communications is the strongest use case. So for example, the person that introduced me to Meshtastic was back at DEF CON because he had one, like, you know, on the backpack shoulder strap. You might have seen people there on their hip or wherever. I was like, Eric, what is that? He's like, oh, it's Meshtastic. You should check it out. It's a lot of fun. And he's explaining to me his use case was he's an avid backpacker. And sometimes when they're in the mountains and you don't have a carrier signal, but you have a couple crews that are going down different trails, you need to find water. We need water. And he would use that as a way to communicate when they're on mountaintops to try to find any kind of resources or just to kind of get back together at camp. And it was actually pretty cool. And he's like, yeah, I was able to transmit 15 miles from a mountaintop. And I was like, with this little tiny thing? He's like, yeah, it was directional antenna, and we sent it right to the other node, and it picked it up. And I was like, wow. So I wanted to figure out, like, what's the longest range somebody's ever sent this? Right there in the Meshtastic document, 331 kilometers. Anybody know what that translates to miles? A lot. That was my answer, too. Swag that guy. We could just ask Google later. It's meant to be rhetorical, but I love the enthusiasm. So it's a long distance. That's totally like blows my mind. The other part of it is the GPS, right? So if you are out camping or like in a wide-scale emergency, I was down there in the cloud on 9/11, and our Blackberries and other phones stopped working. We had no way to communicate. One guy was receiving calls, and I had to like, hey, you know, call my girlfriend and let her know that I'm okay. She's not my wife, but if we had Meshtastic, imagine like the difference the day would have made to be able to just let people know we're okay. And that's what this thing is great for. Right now we have other wide-scale, you know, emergencies going on, and they should be using something like this technology if they can't use any other kind of communication signal. So in that picture on the right, you've got Johnny Christmas, and you see a little bit of Jakku. They're mounting a solar node on a building. So now that coordinate of where that building is, if GPS is enabled, is kind of revealing its position. So may or may not be a good thing. All right. The other cool thing about it that I really like is like the custom features and capabilities. So you could 3D print different cases. You could purchase something that's like this, and then there are STLs out there, so you could print your own case and kind of like make it your own, you know, different color cases and whatnot. There's also a lot of people are building these stations that are solar based. So when I mentioned the solar node, this is what it looks like. I bought the parts, I assembled it. You could see the innards on the top right, and then I gave it to Johnny, and I was like, here's our baby, have fun with it. And since then, you know, he mounted it up on the building, and he's made some tweaks. The temperature in Chicago, you know, it gets kind of cold, right? So that was always a big concern. It's been hanging in there at 15 degrees Fahrenheit. So very, very cool stuff. And you could do all this without a ham radio license. You know, if you do have one, you can set it in there in your configuration. One of the things is once you do identify yourself as a ham operator, you cannot encrypt. It's an FCC regulation. But you can transmit at greater power. So what's the trade-off? Your mileage may vary. What's LoRa? LoRa's been around for a little while. I actually, before I played with LoRa, I was playing with LoRaWAN for some other project to do stuff with sensors. But it's basically that. You know, you put a tag on your pet, you want to know where they are, and the tag could use LoRa as a way to transmit that data to some app in the cloud, and you can find your cat. or your trash can or whatever. It's really that pretty straightforward. And as Matt pointed out earlier, it's running in the ISM band, which is Industrial Scientific and Medical Communications band. In the EU, more trivia, it's at 433 megahertz, or 686 megahertz, but in the US it's 915 megahertz. And there's some other things in there, because if somebody's trying to jam, there's like a chirp frequency. You could set these values so it'll kind of jump around to avoid any kind of jamming, but jamming can still happen. Data rates, it can vary, depends on what your settings are. Your data rate could be 0.09 kilobits, all the way up to the whopping speed of 21.88 kilobits. But it's really not meant for streaming video or sports events. It's small communication, small messages, which is pretty cool. And the encryption, generally, most of the channels and stuff defaults to AES 128 or 256, but it's using a PSK with no forced like rotations or anything. So we can talk about that in a little bit more detail soon. So looking at the security, so before I even thought of like submitting this talk, I did a little digging, and I wanted to find out, is there anything happening out there with Meshtastic that's already a CVE? Or did anyone come up with some method as a way to take advantage of either LoRa or Meshtastic specifically? And there's nothing, unless you guys know something else. We couldn't find it. When I mean, I'm talking about me and Varks and some other folks. So we kind of came up with just a list of what would be the known issues with anything that's radio-based, anything that's open source based. So you can kind of read that for yourself, but I want to focus on 3 different areas because it's a 20-minute talk, and I think I have how much time left? 10 minutes. Oh, I'm doing great. All right, so physical attacks. So these things are tiny, right? If you leave them laying around, somebody could steal it from you. Why would you leave it laying around? You could put it in your bag, or you could put it in your pocket. But you also, if you put it like on a building, who has access to that building? If you're using this for like real work, like manufacturing, in a plant, at a hospital, you want to make sure it's someplace that the regular folks can't get at it. You want to use physical security to lock it down. So this one on the building, in order to get up there, is a trap door that's locked. So you got to climb up this precarious ladder, unlock the door, go through a trap door, walk across a roof that you could see there's no side railings, and then go up another ladder to hit it with a bat or whatever you want to do, steal it. That's a lot of work. That rig probably costs around $200. Most of these cost somewhere in the range of $25 to $30 for the low end ones, but the higher ones, you know, they can start to hit like $80, $90 or more because they've got more features and capabilities. So physical is kind of like, what's the value? You don't need to put $30,000 worth of physical security around a $25 device, but you do want to use like proper precautions to make sure it's available when you need it. Not, hey, how come we haven't heard from the LoRa device for 3 days? So there's another colleague of mine named Calvin. He's in Iowa, so he wanted to, he's also another big enthusiast, and he's doing a lot of outdoor nodes. He put one up on his shed, but when he heard like, I'm in Chicago, and he's like trying to reach any of our stations in Chicago, he couldn't get very far, right? You need a lot of power, you need a lot of things that are not creating attenuation. So he's in Iowa, so he put one on a grain silo. I guess you walk down the street in Iowa, there's a grain silo anywhere you go. So he went up there, he mounted his outdoor node. And I don't know about you, I have archophobia, and that to me is the best countermeasure. Put it up high, I'm not getting it. It's safe. Even if it's a cookie, it's staying there. All right, so the other concern that I have, I'm a big privacy person. I kind of like to keep things quiet and under the radar. So if you're beaconing your location, you're not under the radar. You're kind of like, here I am, come and get me. So there's all these different devices that do beacon where they are, and you can kind of turn that off in Meshtastic, but it's also kind of cool to see how the mesh is being formed. But if you could see, I don't know how clearly you can see, but there's a familiar name in there. There's a picture like of a Christmas tree. You can kind of guess who that is. I'm in there, I'm Heal, but it just says EAL. So you kind of know where people are. And one of the things that I realized with the map is it's really kind of tracking all your movements. So you see these little lines. So there's a line where I went like south, a straight line. I took some other routes on a highway, or the far right one when I was downtown Chicago, walking around, and it literally tracked like all of my movements. I didn't like that very much, so I turned off the GPS feature. Key management. All right, so I got a lot more things to talk about keys. Mentioned my background is a little bit with crypto and stuff, so kind of take this personally. I think everything should be encrypted, even our faces if we could do that, or when we can do that, but everything should be encrypted. So in Meshtastic, the primary channel is using an 8-bit key, which is 8Q equal. So what? It's a public channel. Does it really have to have high encryption? Why even have encryption? Why is the key even there? It doesn't matter. But when you want to create your own private channels, it's going to default to 128 or 256 AES-bit keys. But there's no rotation. And we were in the channel here, the private channel. It's like, oh, there's a hacker comms channel. Here's the key. Well, that kind of defeats the purpose of key sharing, right? You don't need to make it public. Appreciate them sharing it, but there has to be a better way to do that, especially if it's something that might be emergency related, personal related, health related, anything, right? There's got to be a better way. Here, didn't matter. So you can say so what all day long. So things like that, or an ephemeral key. Hey, you want to join, you got this key, one-time use, gone. Best security is the one-time pad, right? Key is gone. So if we could do something like that with Meshtastic, that would be phenomenal. Any of the key management, maybe having some outdoor excuse me. That's better. Maybe having some external source where we're using to create the keys. So Meshtastic uses MQTT, and you can use your device as a proxy to get over the internet. Why shouldn't we do that with some kind of CA, whether it's personal or public? I want to create a private certificate. I'm going to reach out to the CA. It's going to store the private certificate here, and then I can share this public key with anybody. And if I need to rotate it, I can. Why have it? And the devices don't need to create the key. The devices are low powered. They're not built for heavy cryptographic algorithms or anything. Thank you. I kind of read that as 7. It says 5, but I read it as 7. So why not have these I like you. Why not have these third-party or this cloud or whatever generate the keys for us, and then just copy the small file down to the device where it can be stored? So these are some of the things that I'm actually trying to do a rally call. This is not a talk where I want to beat this technology up. I'm reaching out to everybody who's watching and listening, and if you really want to use this technology and let's take it to the next level, I mean, it's only been around for a couple of years. Let's make our knowledge and our practices a part of this. So I'm going to skip ahead a little bit, get to the POC, because I think this is the best part. All right, so this works. So all credit goes to Varks. A couple weeks ago, while I'm working on figuring out some kind of demo where I'm going to sniff the traffic or jam the radios, I'm like, Varks drops a POC, like a screenshot of what he did. He told me how it worked, and in order to do it, I needed to buy something from China that wouldn't get here for like a month. So he's like, take mine. I was like, dude, you're a lifesaver. So he gave me a LilyGo T-dongle. So the way this POC works is you take your phone, you're using Bluetooth, as you guys know, to talk to a device. You have another device that could be planted outside of your target. It does not, and this again, this is for educational purposes. Please do not try this on anybody without authorization, and you do it at your own risk. So now, if you want to plant this somewhere, you can kind of leave it and maybe kind of give it a power source, because the battery's only going to last like a couple days. Drop some bad USBs in the parking lot. Someone picks it up and they put it in, and once it's communicating, it's using Wi-Fi. And it's going to tell you, hey, every 30 seconds, hey, you there? You there? So now you know somebody plugged it in and they're communicating with your devices. And let me show you what happens next. So I recorded this because at a conference like this, I know somebody would fuck with me and try to jam the signal, and I wanted this to work. Plus, because I only have 20 minutes, I'm running this at 1.5 speed. So I should have drank more coffee. All right. And this is on my kid's computer. I had to remove 2 pieces of antivirus software to make it work because he had 4 versions of AV on there, 4 different versions. So when you plug it in, so it's dropping a payload, it's a PowerShell script. Oh no! Why is that not doing that? Shouldn't you just be sharing everything? You're only sharing PowerPoint? I want to share my desktop. Oh, wait, you know what? Getting there. All right. There it is. All right. There's the mouse. All right. This is weird. All right. So we have the 3 channels set up, and what you do is when you plug in your bad USB, it's automatically going to give you a menu. Is it not working? Thought I hit it. All right. There we go. This is fun. So here's the menu command, and it kind of lets you know what you can do. You can drop a payload, do ducky, keyboard, or serial. So here's the payloads being dropped, and that was having a little bit of a hard time, but we got through it. Then I wanted to do an echo hello as like a test. Hey, do I have signal, right? And if it comes back with the menu, that means nope, you forgot something, idiot. So then you type in serial, and you're like, oh, now I can then communicate with this target device. Now the echo comes back. Yep, hello world. Let's launch calc. Let's just see what happens with that. All right, launching calc. Now, this is not my phone. I'm doing this from my phone on a Windows machine. I'm not touching the keyboard on the Windows 10 machine. So then we launched Notepad. I forgot to click focus on Notepad, so I sent a message. Now, think about how this could be a problem. The reason why Varks did this is he works with healthcare companies, and he brought up the scenario of, well, somebody could use LoRa and put a USB stick in a medical device, and they're in the network. And somebody said, no, you can't. He's like, yeah, you can. And they're like, prove it. Okay. Don't tell a hacker to prove something without expecting it to happen. So here we go. He built this POC. He wrote the code on the LilyGo dongle. It's all basically Arduino code. He wrote the PowerShell script. There's my little message just to show how you can send a keyboard stream. And from there, like, what are you going to launch? Like ransomware, open up Outlook. You could do just about anything you can on that machine. So that was a pretty fun POC. Thank you. Which is called RadioJack. So you could go to radiojack.io if you want to see it. You could download the code. You just got to get the equipment. He's telling me to stop, but do you guys want me to go on? All right, this is it. Last slide. Last slide. Hey, the mob spoke, man. The mob spoke. So they're just going to run through the final wrap-up of all the different things that we can do to make things a little bit better in our world, right? Secure those physical devices, right? Use tamper-evident type locks. Use stronger algorithms. If you're using a tool and they have like things like 8-bit keys, do a feature request. Ask for them to do something better. Or you know what? Help them if it's open source. Share keys using rotation schedules and keep them private. Talked about that. Avoid using GPS broadcasting. If you have to do it, turn it on, but then turn it off when you don't need it. You don't want to get hit in the head with a skateboard like I saw happen in Times Square one time with some guy. Not using Meshtastic, just got clobbered with a skateboard for some reason. You know, why let them know where you're at? Pay attention to what's going on in your environment. You know, this POC used a rogue access point, so install things like WIPs or WIDs. Find out what's going on in your network. Don't be surprised that there's some kind of access point sitting there and it happens to be your Tempur-Pedic bed. I just saw a talk a little while ago about that. And then you can have some security to shut that thing down. Also patch, right? You know, that's the biggest problem. When there's firmware updates, and the Meshtastic code gets updated fairly regularly, update your firmware. Take the chance. And then also block USB access ports. I am done. Thank you so much, guys. My big ask, get involved. Feed the mesh. Thanks. Thank you, ShmooCon.